All right, good morning, everybody. Today we're going to do a lesson on angle measures. This is going to be the backbone of a whole bunch of stuff that we do. Yeah? These are going to be terms you're going to be using all the time. It's really important that you get these terms down today because we deal with angles constantly in here, okay? So we need to talk about a few things first. The first thing we need to talk about is the parts of a line, yeah? So let's just say I have a line here. What's the name of that line? Line AB, right? Arrows like this, right? If I write this, yeah, that's just from here to here. That's the line segment. All right, so now we're going to talk about two more things today. Because remember what I said, a line is basically an infinite string, right? And what is a line segment? Cutting it and holding it at two places. Cutting it and holding it at A and B. But there's other things you could do, right? What else could you do? You could cut it and hold it at one place. So if I cut it at A, right, and I hold the B side, right, then this is gone, right? Anybody knows what that's called? If you only cut it at one spot and so it goes in one direction forever. One direction forever sounds like a fan club. It's a ray. It's called a ray. When you name a ray, right, literally think ray of sunlight. You name it from where it starts towards the directions it's going. Yeah? Where does it start? It starts at A. Where is it going towards? Towards what letter though? B. And what you do is you put an arrow above it only in the right-hand side direction. You don't point the arrow the direction the ray is pointing. You just write it always to the right. That's called a ray. Yeah? Make sense? All right. So that's the big three things that you can do to a line. You can just have the line. You can cut it in two places and hold it. You can cut it in one place and hold it, right? So if I cut this line at B and I held that side, what would I call that ray? Right. Why would I not call it ray AB? Right, it's starting where? And you need to name a ray from where it starts towards where it's going. BA. Easy? All right, so the next thing you can do is you can take two rays, right? And slap them together, right? And guess what you make? An angle. When you name an angle, you have to name a point that it starts at, then you have to name the connecting point or the vertex and another point on the line, or on the angle, yes? So if I did this, I could call that, and here's how you do angle. It's looks like a slanted L, yeah? Not like this. That's a less than sign, like that. And you name it, starting at a point that's not the vertex, so what point? A, B, C, but what else could you call it? CBA. You could not call it BAC because B starts here, goes to A, and goes to C. That's this angle. You see what I'm saying? So be very careful how you name them, yes? Angle ABC and CBA are the exact same angle. We typically write them in alphabetical order if we can, right? But if I did this, if I made this angle, and I had these 2 points here, I don't know, A, B, X, Y. I could name this angle BXY if I wanted. I could name this angle AXY, right? I couldn't call it angle BAX because B to A to X, there's no angle there, right? I mean, there kind of is. That's a straight angle, which is a straight line, yeah? But BXY and AXY are the same angle. Yeah? Anything hard there? All right, cool. So let's go to angles, yeah? So we got rays, a line with one endpoint, the vertex, that extends in one direction infinitely, right? Opposite rays. Opposite rays is where you take a ray and you slap it on to another ray and going in opposite directions. I mean, the way I like to visualize that, it's the sun. The light starts at the sun and goes in two directions, actually all directions at once, right? Yeah? But those are opposite rays. Yeah? Collinear rays. An angle is two non-collinear rays with a common endpoint. That is a way overly complicated way of saying this. You don't really need a definition for that. Make sense? It should be obvious. All right. So let's go through these. Ready? Find the following. Three angles with a vertex at J. If it has a vertex at J, you know that that's the middle of the angle. Yes? The middle point in the angle. So let's just name one. Angle what? What do we got? Let's do an obvious one. MJ what? N, or what else? MJ what? MJP. And give me a different one. LJN. Now, you can tell that these are all have the same vertex because look at their middle letter, J. Yeah? Okay, what does collinear mean? Same line, right? So the ones that are collinear right now are these right here. These are the collinear ones, yes? Those are collinear. So I want non-collinear rays. So as long as I don't pick those, I'm good. So which three are non-collinear? I could say JK, right? And we're saying array, so how do I write array? What's the symbol? Arrow to the right. That's array. Ray JK. What else? Could I say JP? No, because those are collinear. What else? You could say LJ, but let's go with JL, and it's okay if they have the same vertex, but they're not the same ray, right? And what else? You could say J what? JN, sure. And there's quite a few more, right? What are opposite rays? Pretty obvious. Opposite directions. So if they're going opposite directions, they have to share a point, don't they? That they both extend from. Well, there's only one option on there. What is it? Not KJ. Do you understand why it's not KJ? Yeah? KJ starts here and goes in that direction. So the other ray would have to go this direction, but we don't have a point over here. So it can't be KJ. It would have to be what? All right, so JK and JP. All right, tonight might be a good night, but if you want to do your when you do your homework this weekend, because this is a Friday in here, is get your protractor. Right? You can measure these with a protractor. Your protractor, you don't have to do this right now. We're just going to eyeball it, okay? Your protractor, what you do, and I wish you could see my screen, but you can't, right? It'll have a point here, right? What you do is you lay if I wanted to measure an angle, I would lay this part on this part. So this point would be this point, right? And then you could get that one and see where it's touching, right? And measure it. And just get within, honestly, within 5 degrees. I'm not trying to be too big on this, yeah? So how would I measure, let's say I was trying to measure this one instead. This one right here. What would I do? Well, I would get this point lined up with this point. I would line this with this, and then I would measure what that is, yeah? And most protractors are clear, so you can just put it up on the screen and see it, yeah? Got it? We're just going to get close right now, okay? We know this is 90, right? So we know that's probably 30, 60, 90, right? That's close enough. We're just going to eyeball it right now, all right? Okay, what do I know about an acute angle? What does acute mean? Okay, do I have a 90-degree angle anywhere? Yes, can you see it? Okay, look, this is a big one in in geometry. Just because something looks the same doesn't mean it is. Yeah? If it looks like it's something, it probably is, but you can't assume it. There is one angle on there that I know for a fact is a 90-degree angle. Which one? MJP, because you see this little box here? That means it's 90. Now there is something else you know. This one has to be 90 also, right? Anybody know why that one? Right, 180 is a straight line, so if that's 90, that has to be 90. That's the only two right angles I know. Now, if I know this is a right angle, then I do know an acute angle, because an acute angle is less than 90. So which ones do I know for a fact are acute? MJ what? MJP is acute. MJN, yes. I'm going to say MJN. NJM is the same one, yes? I know for a fact that's acute. How do I know it's acute for sure? Because I know this angle is 90, and that angle is less than 90, so it has to be acute. Well, what's its measure? Not important, yeah? All right. What's another acute angle that I know for a fact? You could say PJN. You could say LJM. Let's pick one. Let's do LJM, right? LJM. Does everybody understand why I know for a fact, even if I didn't measure it, that I know it was acute? Because I know this angle is 90, and that angle is less than 90, so it has to be acute, yeah? And then what's the next question? Two right angles. Well, there's only two, right? What are they? Angle MJP, and an angle MJ what? K. Easy? All right. What does obtuse mean? Larger than 90. So if I can take a 90-degree angle and slap something on it, then I know it's obtuse. What could I do here? Well, here's a 90-degree angle, right? So if I include this part on it, I know that angle has to be greater than 90. Why? Because this is 90. So what is that? Angle K what? JN. And then I could do it the same thing going the opposite way, right? I could say this is my 90, and then I could put this piece on. And I know for a fact that it's greater than 90, right? Which would be what? LJP. Easy? All right. Next one. KJL. Yeah? Just ballpark it right now. That's about 30 degrees. If you have a compass, you can get closer, yeah? But that's about 30 degrees right there. So how big do you think that is? I don't know. Well, that's about 15 degrees in, right? Does that look about 15? I think that's around 15 degrees, right? Around 15 degrees. If you want to measure it exactly, I can't put a protractor up here. K, am I? K, hold on. Then I'm messing up. That's why you guys are making that face. KJL. Oh, okay. All right. Sorry. I was doing NJP. That's not even an option. Darn. I can't save it. All right. KJL. Where's KJL? KJL is this one, right? This one. What's that looking like? 75. Okay. I'm okay with that. We can measure it for sure to make sure, but 75 looks good right now. LJN? See, what I would pretty much do is like, this angle's almost this angle, right? Right? So that's probably really close to 90. Probably a little bit less, right? 85 would be a good guess. If you want to be exact, what would you do? Get a protractor and measure it, okay? And then we got KJN. All right. Well, that's for sure 90, right? And then what's that? That's about, yeah, about 60, right? So 90 and 60, 150 I think is a good estimate of that. All right. Not really that important to me tonight, okay? This second half is way more important to us. Okay, so read that. We got a new word there. Read example 2. There's a new word. Okay, by means two. Secting is cut. Cut in two. You can bisect two different things. You can bisect a line. Don't write this, but you can bisect a line where you cut it in a place where this piece is equal to that piece. Yeah? You can also bisect an angle. When you bisect an angle, you cut it, and watch this, you're going to see something new. They'll show you this sometimes. If you're bisecting the angle, what they'll do is they'll make the angle with the little tick mark, and they'll make the other angle with the same tick mark. What does that mean? They're equal, which means that line in the middle must have been bisecting it. Yeah? You get the idea behind it? We'll use the word bisect a lot. It's kind of obvious what it is. All right, so what do we know? We know KN what? Okay, JKL is this one, right? JKL is this one right here. So it bisects it, which means this is equal to this. And use that symbol because you'll see it a lot, yeah? You'll sometimes see the tick mark symbol. You'll also see it this way sometimes. And they just mean the same thing. You can write it like that. Or if you have another one, they'll do like a double and a double. But if it looks the same when they do the angle thing, it's the same. We'll stick with the tick mark one, right? Because that's more often than anything. All right, what else do I know? JKN is 8x minus 13, and NKL is 6x plus 11, right? Wow, that is terrible handwriting. 6x plus 11. Yeah? All right, so what do I know about 6x plus 11 and 8x minus 13? They must be equal. So that must be equal to that. Move the 6x over, we get 2x. Move the 13 over, we get 24. Divide both sides by 2, we get x is 12. Not the question, is it? Okay, what's that little m in front of it mean? The measure of. When you put an m in front of it, it's the measure of the angle. So they want to know what the angle was numerically. What do? JKN, I would just plug it in. So JKN will be 8 times 12 minus 13. If your phone goes off ever again in my class, I'm picking it up. Turn it off right now. All right, so what is this? 83? I'll take your word for it. 83. Is this hard? Now, if JKN is 83, then what would NKL be? 83. Could I then, so I know now that this is 83, I'm just showing what else they could do. That's 83. Could I figure out what this angle was? Yes, because those add up to 180, don't they? They're a straight line. So 83 is what? 166, which would be what left over? 14, I believe. That would be 14 degrees, yeah? Okay, all right. Let's try it again. Example 3. Let's see, LKM and NKM. Find JKN. All right. All right, what do I know? KJ and KL are opposite rays, obvious. KN what? Bisects what? LKM. So that means this one is equal to this one, right? What do we know? We know LKM is what? Now I got to be careful. That means this whole thing is 7x minus 5, right? What else do I know? MKM is what? 3x plus 9. Now, I don't know anything about LKN, but I actually do. Algebraically, what is LKN? LKN, this one right here. Huh? 3x plus 9. And then we can do some algebra. 3x plus 9 plus 3x plus 9 must equal? All right, so some BZ algebra, right? So 3x plus 9, you can say times 2 if you want, or you can just write it twice, whatever you want to do, equals 7x minus 5. So we get what? 6x plus 18 equals 7x minus 5. Bring the 5 that way, that's 23. Bring the 6x that way, it's what? 13? That's an ugly number. Did I do my math wrong? Oh, yeah, it's not 20 what?
No, 23. But 6, the x is 1.
Oh. Oh, my God. Okay, that... Wish I could edit that out of the video. They're going to think this geometry teacher's... I mean, if you're ever watching this video someday, I do make mistakes, but you can't see my face. And it's because people usually pay money to see my face. On the side, when I'm not doing math, I'm a supermodel, so... Right, kids?
Yes.
All right. What's the question? What is JKN? Now, that one's a little bit trickier. If I was trying to solve that, I would just solve what I already know. Do I know what MKN is? Yes, because I know what MKN is. It's actually pretty easy, right? It's equal to what? 3 times 23 plus 9, right? Is that 78? I'll take your word for it. That's 78. So that means this is 78, and that means that's 78. Can I then figure out what this one is? Well, yeah, it would be the rest of 180, right? So what's 78, 78? 140, 156? 156? So if I wanted to find that one, this would be what? 180 minus 156. Everybody okay with that? So this one's 24. Now what's the question? I've got them all so I can answer whatever they want now. What do they want? They want JKN. JKN, I'll change my color here. JKN is this one, right? So they want this, which is 78 plus 24, which is what? 102? All right, 102 degrees, right? Easy? All right, let's try one more. I want to look at this one. We're using the same picture here, right? NKL, okay, got that. JKM, got that. Okay, yeah, we can do this one. All right, so we're going to do the same problem again. So I'm going to draw this picture down here, yes? You might want to draw it down there too. Just make something that looks vaguely like that, yeah? All right, I know NKL is 7x minus 9. I also know it still bisects from the last problem. It's doing the same problem again, so the things that were true there are true here. So these are still equal, yeah? So that also means this is 7x minus 9, right? And what do I know? JKN is x plus 3. All right, how am I going to solve this? Yes. There it is. Ideas? Mathematically, how are we going to solve this? Add them all together. Let's do what you said. X plus 3 plus 7x minus 9 plus... All right, equals what? 180. And then it's just some algebra. 7, 14, 15x. Minus 9 is minus 18. Plus 3 is minus 15. So we get net 15x minus 15 equals 180. If you wanted to, you could divide everything by 15 right now. Yeah, I'm going to do that just to show off for the ladies. X minus 1 equals, watch what I would do here. 15 double is 30. How many 30s in 180? So then it must be 12. Yeah, that's right, 6, not 60. 6, right? If 15 was 30, right, if I was doing 180 divided by 30, it would be 6. So it must be twice that. So what is it? 12. You can do it in your head, which makes x 13. All right. Is that the question? No. JK what? N. Well, angle JKN, you could do it a lot of different ways. Let's do it a different way, just because I want to show you multiple ways of doing this. JKN is going to be equal to what? X plus 3 plus 7x minus 9, right? JKN. And then I could just plug it all in there if I wanted, right? So what do I get? If I wanted to, I could just plug in 13 for all the numbers and get the angles and just add them together that way, but this will work too, right? What is this? 13 plus 3 plus 7 times 13. Fun fact, 91 minus 9. What do we get? 91, 101 plus 3, 104 plus 4, 108 minus 9, 99? Can someone check my math? Darn it. That's what I got, 98. I was just testing you guys. Good job, team. I couldn't catch you all. All right, good? Not hard? You gotta draw pictures. Make sure you're showing your work, okay? All right, there you go.